Hey guys, Mr. Riss here. We're going to finish up the 1.2 notes for calculus right now. So the last part, what we're going to be doing is kind of practicing our knowledge of what a graph means, especially when it comes towards limits. And this isn't that difficult of a topic to do, but it seems to be one of those that people either understand it or they don't. And it's one of those things, once you get it, it's really easy and it clicks, but it does take some while for some people. So we're going to take our time with it. So I think a good note to put here is to make sure we understand the difference between what f of a number is and the limit as x approaches that number. So maybe you might want to put some notes here and maybe say like, okay, f of some number, f of c is basically asking, where is the graph or where is the function at c? So this first problem here, I have f of -4. I want to know where is the dot at -4. And I look here, there is no dot. There is an open hole. There's no dot. So there would actually be no hole. So this one would be does not exist. What's different about f of c versus the limit as x approaches c of f of x, this is asking, where is the graph going? So not so much where is it at, but where is it going? Okay, so now if we want to ask, okay, what's the limit as x approaches -4 of f of x? So as we go to -4, okay, this is going up towards 2. We got like 1.5, 1.9, 1.999. But come the other way, it's like 2.1, 2.01, 2.001. So we get closer and closer to 2. So the function does not exist for -4, but the limit does. Okay, so let's make sure we understand and all the different scenarios that could happen there. What about f of 1? All right, so remember, f of 1 is saying where is the dot at 1? Well, we got a closed one and an open one. Technically, our closed dot is our location, so that closed dot would be at 4. All right, now what is the limit as we get closer to 1? So now it's saying where's the graph going? Now as I come from the right side, I'm a little bit about 4, 4.1, 4.01, 4.4. So it's coming from the left side, we're getting closer to 4. Coming from the right side, all right, -3, -2.5, -2. So coming from the right side, I'm going towards -2. Coming from the left side, I'm going towards 4. So the limit does not exist. These are not going towards the same number. So we can't say the graph is going towards one specific location. All right, and lastly here would be f of 6. Well, let's look. Where is the dot at 6? The dot is, well, not at 5 because it's open, but it'd be down here at 2. So the dot is actually located at 2. The value of f at 6 is 2. Now the function as it goes towards 6, as we go towards 6, we're staying on this line. We're getting a 4, 4.5, 4.9, 4.999. Coming the other way, we're at 6, negative, 5.5, 5.001, 5, and we get closer to 5. So coming from the left side, we go towards 5. Coming from the right side, we go towards 5. That number is 5. All right. Now, just to help you out, there is one other scenario that can happen, and we didn't really go over it because you guys have seen this like your entire time. If I say, okay, what's like f of 4 and what's the limit as x approaches 4 of f of x? Well, f of 4 is saying where's the dot at 4? Well, the dot at 4, we're going to just estimate here is at -2. Now, what's the limit as we go towards 4? All right, as I go towards 4, I'm going closer to -2. If I go the right side, I'm also going towards -2. So there's definitely times in where we see that the limit does equal the actual value. And that's going to be kind of the first scenario we go to in the next section, the easy stuff where it works out nice. So let's make sure you guys recap these. All right, if there's a hole in the graph, or even like if there's a vertical asymptote, if we have like a vertical asymptote, the limit does not exist. All right, if we're asking for the limit though, we want to see, are we going towards a specific case? Same thing with like this, we're not going towards a specific number. We just say that does not exist as well, which can happen. We can have both the function and the limit does not exist. All right. Now, if there's a solid dot, we actually have a value at the point, but it only exists if they go towards the same number. And in fact, sometimes we can get numbers for both the function valuation and the limit, but they can be different numbers if we have a solid dot at the one number, but the limit goes towards a different spot. All right, guys, so I hope this kind of clears some things out. This will be something we work on and get into more detail, especially when we start looking at limits as they go towards infinity. And we'll actually be more specific when we look at left and right-sided limits as well. All right, guys, if you have any questions, make sure you ask, but hopefully you're doing all right with this section, and you guys have a great rest of your day. See you next time.